It's actually quite simple, really. I mean, obviously, some of you might have heard of the Hallback array. Well, I have a suspicion that that is basically the principle that's used. Anyway, I'm currently designing a new segment right now. What what the thoughts are is that I just can't believe that there aren't lots of magnet motors already out there, and I'm pretty sure there are actually, and a few people have claimed to have them, but they all seem to disappear down a rabbit hole or out of sight when they have these devices, primarily because of fear of the global situation, where a lot of oil industry or whatever, particularly, they don't favour the idea of us having free energy. So that is the biggest hurdle, really. And even if you patent it, there's no guarantee you're going to be able to make any money out of it, because it costs a fortune to patent it, number one, and patent doesn't work anyway because people can still copy it and duplicate it, and certain countries that we shouldn't mention probably just do it with just duplicate other people's work without any kind of collateral consequences to them for doing so. So yeah, they get away with it, and they can do it, and we all know about the stuff we buy on eBay or the internet, and it turns out to be what people sometimes call a clone. Well, a clone is another term, but it simply means it's a counterfeit, which means it's a copy, or it's not the original manufacturer. So why am I rambling a bit about this? Well, this is the problem. You can't make any money on this stuff. This is why I'm doing it. My research, I'm doing it for free. You know, I'm putting it on the YouTube channel, and hopefully to help people. I rarely ask for anyone to help me out with money, but donations do help, because I don't have a lot of money. I have virtually no money at all, actually, because of my disability and that. But it costs money to buy magnets. I mean, yeah, I've got to buy some more magnets at some point. But I've designed a new segment which I'm printing at the moment. I also fixed this. I've used some drawing pins to hold it down on the table, and I stuck this little plastic thing because I got sick of picking this thing up off the floor, because yeah, it kept rolling off the table. So I stuck this little cotton bud. I just stuck it on with a bit of my plastic glue, so I can play around a bit easy. And I've got a paperweight on that end. I've also got a drawing pin at that end as well, just so that this thing is flat, because it wasn't very flat before, but it's a lot flatter now because it's stuck down on the table, but it's only temporary. Now at the moment, this segment, which is the third one I've done, because I've done two others, this is the third one. I'm printing the fourth one right now, which I'm pretty sure is going to work a lot better than this one. It turns out I don't believe I'm going to need the old Nikos after all. I thought I would, but the old Nikos might not be needed if I use a Hallback array type of return on the exit and entry points, the entry exit point, something like that, to basically switch on the field and switch off the field, which should be more effective. So, because at the moment I am getting a little bit of residual. Now, most of the residual on the entry point is when you turn the segment around to get the feel of the back of here, which pushes this back. So if I push this up to this top end, it's actually, you can see it pushing there, right? But if I rotate it, well, I didn't rotate it much, but if I actually rotate it slightly, we can, I'm trying to get it, go back up there with you, right? So if I rotate, I'm actually a bit close, I rotate it like this, it kicks it back more. But we definitely have forward thrust, but it's only a fraction of a few grams. And the reason I'm mentioning grams is because, even though I've not weighed it, is because I know how much these magnets in this tube weigh, which is just a few grams. And sometimes we actually see deflection when we get it in a certain position. We can actually see, let's push it back down again. Let's see if I can show you that. well, we can see it's pushed it off the thing, so it's a few grams, which is not enough to drive the rotor. Now, I've actually put new magnets in here, so we've got new set of magnets. Got some neodymium magnets in there now instead of the old Nikos, but it still won't turn with the segment. So this is why I'm designing the new segment, because I can't get the rotor to turn yet, because there's a certain amount of back on here. As you can see, it's I've got to eliminate this when I get this in a certain position. Obviously there's some bleed through, some flux bleed through, so if I bring this back, you'll see it move. So I'm trying to eliminate all of that so that we don't have rejection on the entry point, and we also don't have rejection on the exit point, because if you do that, it's basically negating most of the forces that you're trying to harvest or use to drive the thing forward. And it does a pretty good job. I've got this thing tuned up pretty well, as you can see, but the new segment, I'm hoping, should be a lot better. I've also made a space in the centre. Well, I've stuck a piece of plastic down the middle there, because having spaces in the middle helps with the propulsion, but the ends need to be blocked off with a return field, which is why I'm printing this new segment right now. It's going to be a couple of hours, 2.5 hours to print that, but as you can see, it definitely moves this thing. Now if you reverse this thing and turn it over, right, so we're backwards, right, it's actually, this table's not perfectly flat, by the way. You can see that there's not a lot of force there. There isn't a lot of force. So this table's on a bit of a slant, a bit of a slope. This is the problem. So the new one, I'm hoping the new segment's going to have a lot more force. Yeah. So yeah, there's definitely a discrepancy. This is really upside down. Yeah, so there's very little force at the moment, but we should be able to get that sorted out with the new one I'm printing right now. So yeah, upside down should push it back with the same amount of force that we're pushing it forward, but let's try that again. It's pushing it, but no, it's not a lot of force. It's probably less than 2 or 3 grams, or maybe 5 grams or something. It's not significant enough to do. Obviously, if I get too close, the trouble is this thing flies across and sticks to it. So the new segment should eliminate all of that. Fingers crossed. You know, when it does this, when it kind of gets too close, and I've got it upside down right now. When it gets too close, like sometimes it'll stick. Like when it gets there, it sticks to that point there. This is a weak area. This is a bad area, because it likes to, oops, I'm not pointing the camera. At this point here, it tends to want to stick to, which is another thing I've got to eliminate. So the new one should eliminate all of that. We'll find out. So maybe tomorrow, Sunday, I can show you an update with the new segment, which I'm printing right now, and we should have something to show. Fingers crossed. Yeah, I've been a bit depressed actually. I've been watching all this stuff on GB News as well. gbnews.uk. Well, it's all this stuff that's going on the internet. It's just very depressing right now, and I'm hearing all these stories about the vaccine. Yeah, I'm sick of hearing all this negative stuff. I really am, but living in denial is not the answer. You've got to know what's coming. I mean, if somebody says the bridge is out, you can say, please don't tell me that. Well, that's kind of stupid, because if the bridge is out, you're going to drive off the cliff, right? Psst, you're dead. So it's sometimes a good thing to know negative things, even if you don't want to listen. But at the same time, I've heard it all before. I know about all of this negative stuff. I'm kind of on overload. I just don't want to. Yeah, I kind of want to get off this damn planet. I'm really sick of it. I really am. Yeah. So anyway, I'm sidetracking. Sorry. Yeah. So I haven't got my other. I'll move my fags out of the way. I haven't done the rest of my segments for the motor generator yet. I've got to finish these. There's only about 4 left to do, but I've been focusing on the magnet motor for the last couple of weeks. So I've got most of them done. I just haven't had a chance to get round to finishing these off. I think there's about 3 to do actually. They've got a bit hard now because the acetone's really dried out. They've got really hard. I'm probably going to have to soften them up again before I actually continue with that. Sorry I don't have anything more to say right now, but I think we're all in the same boat with this situation. In some countries they've got it really bad. Yeah, general stuff going on. It's just really, really depressing. Anyway, yeah, if you just joined, I'd just skip to the beginning and watch what I was explaining again, because I think I covered just about everything. I just really can't give you anything more at the moment, other than the fact that I've spent ages and ages and ages in SketchUp moving these frigging magnet slots around and trying different configurations, and the only way that it seems to work best is if you open the magnets out like that one there, where this one's a dual position. I can push that magnet out and it'll go into 2 positions, so on the exit point. And I've tried it in different arrangements, and that's the only arrangement that seems to work with that. So this is why I've opted for a completely different arrangement, which you'll see on the new segment. Actually, I'll give you a preview. Let me just load it and I'll show you the new arrangement. I've got to get the YouTube video out of the way because it's blocking the screen. So I'll show you the new layout. Right, so I'm going to zoom in, hopefully. Alright, sorry about the wobbly cam, because oops, I'm a long way from the computer monitor. So that's my new layout. Oops, I want to get this round a bit. Right, so that is what I'm printing right now. So I think that's going to work really good, because the ends are basically subtracted. The end is subtracted and we have deflection on the exit point there. And on the entry point we have attraction, and then it transitions across to the array, which carries the magnet rotor through to the exit point where it's then kicked out. So we have an entry kick in and an exit kick out, and we have a rolling motion between the entry and exit point. So yeah, sorry I'm really wobbly right now. So that is what we're going to try next. I've got to zoom out again. Right, so I'll come back tomorrow and show you some tests, because I didn't sleep very well last night. It was too hot. I woke up sweating. You know, it's just been hot and sticky lately. So yeah, thanks for coming and joining me and everything, and take care. Bye for now.